I'm Mike Coleman. I'm here from Docker today and take you through this workflow, what we call build, ship, run, which is sort of kind of a cute 3-word description of what Docker does. At the end of the day, what Docker enables is application portability across, we go as bold as saying like run any app anywhere, which I think is a pretty bold statement, but that's sort of the marketing tagline. Before we drill into how we facilitate that, let's do some common vocabulary because I'll use these terms repeatedly and I want to make sure everybody's on the same page. A Docker image is the most basic level, most basic primitive in Docker, right? So the Docker image is basically how applications are built. It's akin to a golden image in VMware, right? Just sitting there on the disk. It's not doing anything, and it's the basis of the Docker container. A Docker container is what you get when you instantiate an image. So you say Docker run, you give it an image name, and that creates the container. So the container is the runtime instantiation of the Docker image, right? And the difference between an image and a container on a technical level is a read-write layer on the top of that image, right? So some cool things about images, and you see this with some storage technologies that allow the same sort of thing, but images inherently share underlying layers. So an image is made up of layers, right? It's got a base layer, and then you add in your software, your libraries, add in your code. Each one of those actions creates a layer, and those layers are shared across images. So if I was to build 5 different images, all based on an Ubuntu image, I would only have that Ubuntu image there one time. And if I was to deploy 5,000 containers, I would have that Ubuntu layer one time, and I would have the image layer. Each one of those images would be represented one time, because they're just read-only things. So everything gets redirected back into them. And then Docker Engine, as we sort of mentioned before, Docker Engine is that piece of software that does all the coordination, right? It is not a hypervisor, but it fulfills some of the same roles that a hypervisor does with regards to controlling the state of the container. Start it, stop it, pause it, create it, destroy it. It's not a hypervisor because once a container is instantiated, it's a Linux process. And so it just operates as if it just thinks it's the only thing running on the server, right? So it doesn't go through a translation layer. It just accesses hardware directly, just like any process on a Linux server would. And I say Linux repeatedly, but with Windows Server 2016, we'll have Windows Server containers, and they work in the same way. And then we're going to show you some commercial management tools. We are an open source project, but we have commercial tools. We have an offering called Docker Data Center, which is based around Universal Control Plane and Trusted Registry. Universal Control Plane is a web-based portal to manage and deploy containers, as well as storage volumes, networks, Docker images, groups, all kinds of stuff. And we'll go into that. I'll show you a demo of that. Trusted Registry is where you store your Docker images. You can put them inside your firewall, right? Inside your firewall, meaning in your private cloud, in your data center, so behind your VPN, whatever that is, in your VPC. On the other side of that, we have a couple of SaaS-based offerings. Docker Cloud is a SaaS-based management portal, and Docker Hub is a SaaS-based registry. And so you can do on-prem with Docker Data Center, Universal Control Plane, Docker Trusted Registry, and you can do SaaS-based in the cloud with Docker Cloud and Docker Hub. So depending on your use case and your needs, those are the tools you would use. So
Docker Hub can be, is it multi-tenant? So can I have my tenant and deploy my containers from Docker Hub? So it's just for me.
Yeah, so the Docker containers are fully isolated, so they are they're not going to communicate across each other unless you want them to. You know what I mean? Like you can spawn 2 containers and have them communicate because one's a web front end and one's a database. So yeah, they can coexist. Some people have a more stringent requirement for multi-tenancy, and that's a strong use case for putting them in a VM because people are like, I don't want to share a kernel. Like they're like, I don't want to share a kernel. And so then you put it in the VM and you have the shared, the isolated CPU. But the reality is the isolation on containers is very strong and they can exist side by side. We can also do some things with networking, which we'll talk about in the next session, that make multi-tenancy even sort of more isolated. So build, ship, and run. So the question is, why Docker? And why Docker comes back to solving a very, early in the, just like VMware had its roots in solving the problem, the very first problem VMware solved with virtualization was capacity, right? It was server density and getting workloads, pretty well loaded. The first problem I think Docker was aimed to solve for a lot of people was it doesn't work on my machine, right? So you build a piece of software and you run it on your laptop and you're the developer and you're like, bang, bang, yeah, this is great, I'm stoked on this. And you throw it over to Jan and he's doing our QA and he's like, boom, boom, I'm stoked on this, it works. And then we put it into production and something doesn't work, right? Something doesn't, there's a library mismatch or there's a config file that isn't right, some little tiny thing. With Docker, when you build a container, everything you need to run the application is in the container, right? And it's hard for me to like use it without using the word container, but it's all containerized, right? And so if you think about build, ship, run, I'm a Python developer and you're a Java developer, right? I will give you my Python app in a container. You will not install Python on your machine. All you will have is a Docker engine. You will run my application. When you are done with it, you will remove the container. You can remove the image and there's nothing left behind. Once your application is put in a Docker container, it runs on any machine that has an application. That machine can be a Raspberry Pi, as I mentioned. It could be an EC2 instance. It can be an Amazon instance. It could be a vSphere VM. It could be a KVM VM. It could be a physical host. It doesn't matter. We have development tools. So the first tool you'll see me use today is something called Docker for Mac. And we have Docker for Mac and Docker for Windows. And they allow developers to work in their native operating system. They create that Docker image, then they ship it, they store it up to a registry. We talked about Docker Trusted Registry, Docker Cloud, or Docker Hub. And then from there, we deploy it out and we run it. But what we know is that once we do that, we know that we're putting out the same artifact. And we have features in Docker to really drive that in a secure fashion. We can digitally sign these images and ensure that they are the image that you believe they are and they've been pushed out by somebody that you trust, right? And so securely developing and pushing images into production and ensuring that they work, right? The other part of it is, the other big benefit is the performance, the scalability. So if you have to scale up dramatically, a lot of customers who, one of the first big use cases was CI/CD. And if you think about like scale testing a virtual machine and you have to fire up 100 instances, that's gonna take you a little bit of time to do. If you do 100 instances of Docker and you have to scale out to 100 instances to do testing, the Docker, the containers fire up in 3/8 of a second. So in about 30 seconds, you have 100 containers running, right? And you're not going to have 100 VMs running in 30 seconds. The
question on that. The snarky way of saying is like, okay, I'm turning a VM really quickly. It's like building a data center. I only have to do it once. So who's turning on 7,000 containers in under a second? For who is that a use case?
So it's a use case for in some businesses it's seasonal, and some businesses it's during the day. So we have an example of an online retailer that they do flash sales every day at noon, and so their traffic at 11:59 goes through the roof, and then by 2:30 they're sold out and they don't need it, okay. Right? And they can respond that way, right? It's also a sense of like you can start doing things differently than you did them before, because when a container dies, like optimally containers by their definition don't store state when they're deleted, right? So information in the container is lost. But you can start doing things like you can take a container down and bring it back up in 3/8 of a second. A user may never even know the container went down. Like when we update our load balancers, like we have a load balancer thing that we do that we update, and we do that by updating the config to the load balancer and bouncing the load balancer, but it happens so fast, like in a fraction of a second, that in essence, it's like it never went down, right? And so it's not just about like, I want to deploy 10,000 containers. And oh, by the way, for people doing QA cycles, they may not be doing 7,000, but they're standing up multiple instances of these applications during the day, and that's another example where people are doing it and where that performance really matters.
So it's frequency of activation rather than just, hey, I want to turn a lot on really quickly.
Yeah.
I can increase my cadence.
Yeah, you can be more, and there's a whole bunch of agility messaging around like when you go to microservices and containers, like your application agility, and we'll get into this. We talk about customer case studies if we get that far, but what people are seeing is like they're taking QA cycles that were hours or days and bringing them down to minutes and hours. Like they're just drastically reducing the time. And the other part when we talk about CI/CD is you take something like Jenkins that has a worker node. This is my worker node for Java. Right, and this is my worker node for Python, and it's got to be exactly right. Well, If you're running in a container, this is my worker node, and it's got Docker, and I don't care, right? I'm just going to put my container wherever it lands, and I don't have to worry about all those dependencies. So that's another big benefit.
Yeah.
So, so with that, let's do a demo, because I've been talking now for going on a half an hour, and I've not shown you the product. So we are going to do what we call a build, ship, and run demo. So I have got here, and I am now a developer, and I am not a developer, but I'm going to play one during this demo. And I am building a great application, and it is called CatWeb. And CatWeb is built from a Docker file. And a Docker file basically is how you construct a Docker image. So if you are a Python developer, or if you've done any Python development, this will look extremely familiar, because these steps are exactly what you would do to install your application on a physical machine. You would start with some operating system. In this case, we're starting with Alpine. Alpine is a very small Linux distribution. And we're going to add Python. So here we're telling the Docker to install Python into this image. And then we're going to, and pip. And we're going to upgrade pip. And then we're going to use pip to install all the requirements. So in this case, I need a couple libraries for my Flask application to work, and I'm going to install those into the image with these commands. And these commands literally, like, this is what you would type at the command line. You would type pip install blah, 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 if you were actually doing this sort of in a native way. Now I'm going to copy my source code over to this directory in the container, or in the image. And I'm going to copy a web template over into this directory in the container. And when it's all done, my application runs on port 5000, so we're going to tell it to expose it. And when the container starts, we're going to instantiate Python and point it at this application file. Those steps are almost identical to what you would do in a physical environment. I said that 3 or 4 times, but the important part is, as a developer, I'm not actually asking you to really extend your mindset that much. We've added a couple of commands like copy and run, which are pretty intuitive. So what you get out of that is a Docker image, right? And so I already have the Docker image loaded onto my machine because I've been working on this app. So Docker images shows me those images. And the one I'm working with here is I'm going to be working with CatWeb. And that's my application. So let me just run it. And I'll explain all this in a second. It's just easier to type. And so I'm just little cut and paste because it's so long. You'll notice that long thing at the end there, it kind of falls off the screen, but basically that says DTR demo US West Cloud Web App Azure.com demo user CatWeb. That is the address of my Docker Trusted Registry. The first is the URL of the actual server. Mine's running in Azure, and then demo user is the user. It's my account. So we've got these Docker Trusted Registry. You can use groups and users to secure it. And place images into secure repositories up there. CatWeb is the application. So when I hit enter, CatWeb is now running on my local machine. So I've now instantiated CatWeb on my Mac. So if I come over here and I say localhost 5000, there's my totally random cat GIF of the day. CatWeb will be taking the internet by storm, but I've got a branding problem. Nobody knows who Nathan is. So we're going to change the branding. So I'm a developer, I'm just working, I'm hacking. So I'm not a developer, so all I can do is use my favorite IDE, VI, and I'm going to go ahead and edit the web page, because I do know a little bit about in HTML, and I'm going to come down here. And I'm going to delete this word, and I'm going to change it to Mike. Oh. I'm going to save it off. So I didn't show you this command here, so let me back up. What I've said to Docker here is when you instantiate the container, take my current working directory, pwd shows the working directory, and mount that into the container at user source app, which is where the source code goes. So the container is running, but it's taking that particular directory using something called a Docker volume, and it's pulling it off my MacBook, which means the change that I just made on my Mac file system is immediately reflected into my running container right here. So as a developer, I could be working on my application, changing my source code while the container is running, and I can see those changes immediately reflected. What we'd like to say is that as a developer, I don't really have to change the way I write software. I use the same tools, the same IDE, and it just works. Okay, so enough fascinating CatWeb. One more maybe. Oh, that's a rat and a cat. That's pretty scary. Then what do we get on? There's one in here that never comes up that's pretty funny, but anyway. Oh, this. Anyway, all right. You've seen how many times I've done this demo, right? I know them all. Okay, so, all right, so that's cool. So we've built a new version of CatWeb. So I'm going to go and I'm going to go ahead and I'm going to build that, and I'm going to call that. Oh shoot! I'm going to do this because I'm so lazy.
I would make it build also.
Build or
Yeah, I will. Yeah, I'm not gonna bold. I'm not gonna bold it. I'm gonna build it. Thank you very much. We're gonna come over here and we're gonna Docker build, and I'm gonna give it a name. So I'm gonna tell it to go up there. I'm gonna give it a version. I'm just gonna call it TFD. So we can tag these things with version numbers so they can have multiple versions up on your registry. So if you need to roll back, it's easy to do. And I'm gonna say period, and that just says in the current working directory, process the Docker file. So what Docker build does says take that Docker file we looked at. Run through it. If there's any changes that we need to make, update the image to the latest version. So we'll do that. Send it the context. So it's going to go through and run through. This takes like 30 seconds to a minute to do. But you can see that it's actually running through and it's actually executing those commands to build out the Docker image. And the result will be about a 65 meg image. So while we're doing that, let's go ahead and take a sneak peek at a couple of these other components. So this is Docker Trusted Registry, right? This is where CatWeb is ultimately going to live. So if I click on CatWeb, I can come in here and click on tags, and you can see I pushed 4 different versions up here, right? So I got multiple versions, so I can roll back if I need to. I've also got some cool features around users and groups. So we have role-based access control, and we integrate with both LDAP and Active Directory for user provisioning. So you can have a local database of users, or you can integrate to an Active Directory or existing LDAP. And then this is Universal Control Plane. And what Universal Control Plane does is it allows you, as I mentioned before, to sort of manage the life cycle of your container. It's these two products are commercial. What I've shown you previously is open source. And so what the build, ship, run workflow is basically push it to Trusted Registry and deploy it using Universal Control Plane. So let's go back, still going on this. So let's take a little deeper look here. Again, so this idea of users and teams, we can come in here and we can do full RBAC. So we have a number of different visibility levels to containers. Like I can see a container, I can start and stop it, I can actually instantiate it, right? Different levels that you can apply based on something called tags. So you can tag an image or a running container, assign that to a team or a user, and then they will have secure access to it. Some other things in here, we talked about the authentication methods that we have, so managed Active Directory LDAP. We have the ability to control where containers run. In this case, we've got a UCP instance that's basically it's three manager nodes and 2 worker nodes and 3 nodes for DTR. So we have, the thing is that we're based on Swarm, which is a Docker technology, which allows us to be very fault tolerant and deploy in high availability, which is what we've done here. We have 3 controllers in a high availability mode running on Azure. See where we're at here. Okay, so it built. So it's successfully built. So now I got to get it up to Trusted Registry. So I say Docker push, and I give it that name and that tag, and it takes that image and it pushes it up onto the Trusted Registry. So we're kind of at the mercy of the Wi-Fi here, so this could take a little bit of time. But in the interest of time, because the Wi-Fi is sort of futzing out on us a little bit, I'm going to go back and I'm going to deploy a different version that I already have up on DTR. So if you remember, I go to Trusted Registry. So go back to Trusted Registry. I've got multiple versions of that application. So if you go to repositories, CatWeb, and tags, you can see I've got a number of different versions. So I'll deploy one of these versions. And I'll come back over here. So we'll say container, deploy container. So now I'm the ops team. So you've told me, we've gone through our QA steps, we've released it, we've said it's ready to go. How do we actually deploy it? Well, we come over here and let's deploy version 2.0. And we come down here. Remember, I did that thing where I had to expose the network port. I did that P5000 to 5000. So I'm doing that here in Trusted Registry, Universal Control Plane. And I'm using a load balancer. So I need to come in and specify a couple of parameters. So I talked about that load balancer being able to dynamically sense when a container's been started or stopped. It does that through the use of labels. So if I say interlock.host, and it's www is the host, and I say interlock.domain name, and we're going to find that at catweb.local. It knows that when we hit this, when a request comes in for this IP, this DNS name, that it's going to serve us this container image, right?
Question: This is all drivable through an API, I assume.
Yeah, so we the really cool thing. So people will say, well, there's other orchestration solutions out there. One of the very cool things about using Universal Control Plane and Trusted Registry is that they are API and CLI compatible across the board. So you just know that your workflows stay the same. But all this is drivable through an API. There's also a CLI that you can do this. You can download a bundle that gives you the right sort of environment variables and whatnot. So you can do this all from the CLI as well. I'm just using the GUI to show you the GUI, but we could have certainly done it from the CLI or through APIs. So I hit run container, and you see how fast that came back. That container has now been deployed. So if I come over to containers, you can see here's CatWeb 2.0 running, and you can see you know, all the various things. Like there's the labels that I associated with it. So now if I come over here and I say www.catweb.demo, it failed. All right, well. It's a sad day. Trust me, it normally works. I don't know what happened, and I have like no time to troubleshoot it. But to make you all happy, I'm just going to leave you with the other pictures of the CatWeb, the GIFs.